Okay, so one issue then that arises when we run this estimation, comparing the manual tree output and then the output from R, using the derivmkts package available in R and RStudio, is that while I ran the estimation and the value I obtained here of 727 for a 4-step tree for an American call option using these parameter inputs is consistent with the result that I had obtained on the R output for the derivmkts, the same result. There was an issue then when I looked at the manual tree, which is available here, set up here in this part of the spreadsheet, and I have a link to that which I will leave in the hyperlink I'll leave in below in the video, that the results obtained here for the tree, for the option price tree, differ. Now, when we examine initially at the terminal nodes, we can see these set of values here are consistent with the values that we have here. But then when we perform the backward recursion, we have 349 or 3449, because this is scientific notation, and 1051, those values are not consistent with what we have here. The reason why they're different is because this was originally set out for a European option, and the specification is not European. Actually, we're talking, it's an American option we want to estimate. So I have to make one fairly significant change here, and that is I need to compare the time value, the continuous value, against the stopping value. So with an American call option, you have the right to exercise early. When we pass the values of the option price tree back to the successive nodes, so from the terminal values to the penultimate values and so on, we must perform more than just backward recursion. So we have to ensure in the stock price, in the option price tree, which is what I have here, that the values obtained are consistent with the option price tree for R. We have an issue here that with the American option, we must take the greater of the maximum. We must allow for the possibility that you can exercise early. So if we were to write that more correctly, perhaps we could view here the stock price tree and then set that against the option price tree. And of course, this is not for European. This is for European, but we're actually trying to value an American option. And to switch to the American specification, then we need to include in here the maximum of S minus the exercise, let's F4 that, comma, close brackets over on the other side. And so now we get 3499, and we can compare that against the value that we have here, which looks the same. So to juxtapose both, to compare both sets of values for the option price tree in the manual setup. Okay, now also we need to do that for each and every value, but for this value here, the value we have 3499, that's consistent with 3499, and we can pull that down, 1052, and you can see here we have also here from the R output 1052, and if I drag it down again, 00, that's fine. Pull this value back. Now in this case we have maximum, so we're allowing for early exercise, and we have 22. So this is to the power of 10 to multiplied by 10 to the power of 1. And again, we drag it down, and the value the early exercising here doesn't produce any additional value. And that we can also observe in the tree. So an interesting element of the tree here, the early exercise region, is filled in this derivatives markets package available in RStudio, available in R generally. The green here allows us to identify where in the tree early exercise occurs, and we can kind of see that from the estimations we've been running. Right now, when we pull back again, the value we get here, 1294 down, and then pull this back, and again allow for a few decimal places to compare accuracy. And now we can see the result we obtain here of 727 is consistent with the output from RStudio, so 727 2466. So that value is the same. This value from R is the same, and the value from the VBA formula 27. Let's allow a few more decimals. It's the same. And again, the VBA code here, if we look to examine this VBA code, right, go into the developer tab and notice that in the developer tab, right, for the Cox-Ross-Rubinstein code, we made an adjustment here with Q. Q denotes here the dividend. We didn't originally put that in. We now have, we didn't have specification for Q. Q denotes dividend yield. We don't actually have to change any further code here, except here we must, for the risk neutral probability, calculating the Cox-Ross-Rubinstein risk neutral probability, include in Q also. Otherwise, the code that we have here remains the same in terms of VBA. So again, in terms of overall, how do I perceive and understand here the derivative markets package in R? It's a very useful package, namely because we can produce the stock price tree, the Cox-Ross-Rubinstein tree, and also in that code, it's possible, using the derivative markets package, we can estimate a Jarrah-Rudd tree, and there's one other tree as well we can have a look at later. Interestingly, the outputs we get for the P, so the parameter outputs, we have parameter inputs, including S, K, V, R, T, D, and N, and the parameter outputs P, U, D, and the time step. We manually calculated these here in the spreadsheet. The values are consistent. Again, that's also something that is clearly of benefit. Okay, so looking at P here, the way we estimate P is consistent with how we estimated P here in the VBA code. So the numbers we get tally, the manual estimation in Excel tallies with the results from the R output. That's very useful output. The option price tree is also very useful in terms of understanding the dynamics. We can also see from the tree that there's early exercise. That's here in the, we obtained that using the binom plot function in R, and we can see here that the early exercise tree, right, so the exercise tree, the green here denotes early exercise. So for a put option, for a call option, American call option, with these parameter values, including a value of 5% for Q, right, including a value of 5% for Q, we get early exercise. So call options do exercise when the dividend is positive, or can exercise when the dividend is positive, and we can trace here the early exercise nodes in the tree. So when is it better to exercise early? The option right, is when is the stopping value in excess of the continuation value. Okay, those nodes can be identified in the exercise tree, and we also can exercise visually here in the output that's made available from the derivmkts. Okay, so overall, in terms of visualizing the American option and the dynamics, I think the derivmkts offers a lot of assistance here and very, very useful. Okay.